In this training byte, we will use the BGA generator to create our BGA component, which defines the interface from the package to the printed circuit board. Byte, we defined the cross-section for our 8-layer substrate, and we see that we currently have no pins defined on the L8 base layer of our package. Our BGA component will have pads on this base layer, and this will be the interface from our IC package to the printed circuit board. Our BGA will have 420 pins in a regular pattern, so it is a good candidate for the BGA generator. To start the BGA generator, we'll click Add, Standard Package, BGA Generator to open the BGA generator. We'll name our BGA BGA 420. We can export our BGA into a library for reuse, and this will be the symbol name in our library. We'll use a reference designator of IO1, which is how we will reference this component in a netlist and in reports. The BGA component defines the outline of our package, and the origin of our design is the geometric center of our BGA component, so our origin will be at 0, 0. The information we have about our BGA component is viewed from the top of our design, and in APD, we always view from the top of the design, so we will not mirror our symbol. However, when we define the pads, we will define the pads to be on the base layer. The BGA generator is pre-programmed with JEDEC standard packages, but ours is custom. It will have a width and height of 22.5 mm, and our pin arrangement will have 22 rows and 22 columns. There are 7 rings, which gives us our 420 pins. The pin pitch is 1000 microns both horizontally and vertically. And our edge spacing from the edge of the outer BGA pads to the edge of the package is calculated for us. The pin-use ratio panel of the BGA generator will quickly give us a first pass at power and ground pins. The pin-use ratio is used to set the percentage of total pins that should be reserved for power and ground. The ratio you specify will be turned into a repeating pattern of pin uses. We will have 1 power and 1 ground pin for each set of 5 signal pins, giving you 60 power pins and 60 ground pins. Pins can be swapped later, or if the power and ground pins are predefined, you can set the number of power and ground pins to 0. The generator will automatically create a pad stack for the BGA balls named BGA_pad on our L8 base layer using a circle of 500 microns. You optionally could use an existing pad stack in the design or load a pad stack from UPadStack library. Our pins are numbered horizontally using letters vertically, starting in the top left of the package when viewing from the top of the package. Using the JEDEC standard pin numbering will automatically skip the letters I, O, Q, S, X, and Z. A preview of our BGA component is displayed, and we can use the back button in the generator to go back and make any changes to the information in the generator. When we click the Finish button in the BGA generator, the BGA component is added to our design. The pins are on the base layer of our design, and these will be the interface from the IC package to the printed circuit board. Let's highlight our power pins in red and our ground pins in green. Now we can see the pattern of power and ground pins that was created by the pin-use ratio panel of the BGA generator. The signal pins do not have a net assigned to them yet. These will be assigned as the design progresses. In this training byte, we use the BGA generator to define the BGA component for our IC package.